This is Professor Derf Seitz. This algebra tutorial is part 3 of a series on solving quadratic equations. Part 3 here is completing the square. To complete the square, you need to start with a binomial of the form x squared plus b times x. Then you take the linear term coefficient, which is b, take half of it and square it. When you add that, you have created a perfect square trinomial, and it's the square of x plus b over 2 squared. Similarly, if you have a minus instead of a plus, you still add b over 2 squared, and this time you get x minus b over 2 squared. This is the basis for this technique we'll use to solve quadratic equations. Note that the coefficient of the quadratic term, x squared, must be 1. If it's not 1, you must first divide through to make the coefficient of the leading term 1. Completing the square is used to prove the quadratic formula. To solve a quadratic equation, the quadratic formula is simpler to use than completing the square. However, completing the square is a useful technique not only to prove the quadratic formula, but also to put general form conic sections in standard form. If you don't know about conic sections yet, that's okay. It's good to see how something you're using can be applied to something you'll need later. We will show an example of this for a circle, which is one of the degenerate forms. Well, it's a form of an ellipse of a conic section. Example 1. We have a quadratic equation, x squared plus 10x plus 11 equals 0. We can't solve it by factoring or through the square root property. What we'll do is move the 11 to the right hand side by subtracting 11 from both sides and getting negative 11 on the right. Now we have x squared plus 10x. On the left, we'll complete the square, take half of 10, which is 5, and square it and add that. But since we have an equation, we have to add it to both sides. You can see in red that 5 squared is being added to both sides. That's the completing the square step. Now, on the left, this produces a perfect square trinomial, which is the square of x plus 5. And on the right, negative 11 plus 25 is 14. Now, we apply the square root property. Because we have something squared equals 14, we can write this as x plus 5 is plus or minus the square root of 14. So completing the square is used in conjunction with the square root property. Subtracting 5 from both sides, we get our two solutions, negative 5 plus or minus the square root of 14. Example 2, we have a quadratic with a minus for the linear term. This also cannot be factored or solved directly with the square root property. We take the constant term, subtract 1 to move it to the right, get negative 1 on the right, 0 minus 1. To complete the square here, we take the 3. We don't worry about the sign, it's going to be adding. We take the 3, divide it by 2 to get 3 halves, and we're going to square 3 halves. Again, we have to add that to both sides. This produces, again, a perfect square trinomial of the form x minus 3 halves squared is equal to negative 1, 3 halves squared, square the numerator and square the denominator, is 9/4. Negative 1 as fourths is negative 4/4. Added to 9/4 gives us 5/4. Now we use the square root property. So we say x minus 3/2 is plus or minus 5/4. Adding 3/2 to both sides, x is 3/2 plus or minus 5/4. Converting the 3/2 to fourths, that's 6/4 plus or minus 5/4. That gives us two solutions, 11/4 or 1/4. Finally, we look at the equation of a circle in general form. It has two variables, x and y, but we can use the completing the square technique here to get it in standard form. So we look at first the x's. We have x squared minus 4x. If we take half of 4, that's 2, and square it, that's 2 squared. If we look at the y terms, the linear term is a 6. If we take half the 6, that's 3, and square it, we would add 3 squared to that binomial. So we've added a 2 squared to this binomial phrase and a 3 squared to this binomial phrase. We have to do the same thing on the right, add a 2 squared and a 3 squared. This trinomial here now becomes x minus 2 squared, and this one becomes y minus 3 squared. On the right, we have 3 plus 4 is 7 plus 9 is 16. This is an equation here of a circle in standard form with the center at 2, 3. We have a graph of this circle. There's the center, 2, 3, and there's the equation. We see that completing the square is very important because it proves the quadratic formula, which will be the subject of part 4 of this series, and also we've seen its usefulness in transforming general forms of conic sections to standard form.